This is video number 2 for section 510. Okay, this actually went with the example 1. It was just showing there are a lot of different shapes and sizes of boxes that would have the different volumes. So let's go on to your guidelines, which you could probably read these on your own. The one thing I wanted to point out that's a little different in these notes is I tend to, when I solve these, I think about what I'm given and what I need to find. When they reference primary equation here, that's what you're finding, and secondary equation is what you're given. One thing that we didn't do in the first problem was determine a feasible domain for your primary equation. So that sometimes comes up. It sort of depends on the problem. All right, so the next optimization problem we're looking at finding the minimum of a distance. So it says which points on the graph of 4 minus x squared are closest to the point 0, 2. So I graphed the parabola. It's kind of a sketch. It's not exact. So it's an upside down quadratic, shifted up 4. And then there's the point 0, 2. So again, pause the video. You could pause the video and write all this down right now. We're finding which 2 points on the parabola, so I just sketched a couple there, are the closest to this point 0, 2. So that is a distance. So what we're finding is the minimum distance. Distance formula, you probably forgot, is this: x minus x squared plus y minus y squared, square root of all that. And then we are doing the distance to this point. So we know one of the points. So if I'm finding this distance, I know this x and y. I need to find this x and y. So if I substitute in 0, 2, this is what I have. My given is just the equation of the parabola. So that is all that is given. So remember, we're going to want to rewrite this equation that we have to take the derivative of in terms of a single variable, and we're going to use this right here, which says y equals x squared. So let's start. I'm going to move over here, and this is my distance formula. I'm going to simplify it a little. X minus 0 is just x squared, and then plus y minus 2 squared. So that I want to write in terms of a single variable. So I'm going to replace the y with 4 minus x squared. So I'm going to have x squared plus 4 minus x squared minus 2 squared. Okay, so that's going to be square root of x squared plus 2 minus x squared squared. 2 minus x squared squared. So just combine those like terms. Okay, now I need to take the derivative of that. There's a couple ways you can do this. I'm just going to kind of do it a little different. This is a chain rule. This would be a chain. It's a double chain. This is a chain, and the square root is a chain. I'm going to square both sides to kind of get rid of that square root, which might not have occurred to you, but I think it makes the derivative a little bit easier. So now I'm going to take the derivative of both sides. So if I take the derivative of this, I'm going to get 2d, but this is not an x, so this is sort of implicit, right? But this is what I'm finding, the derivative of d with respect to x. So I'm going to say, this is 2d times d dx. And then on the other side, I'm just going to do this derivative. And this is chain rule. I'm going to write it. And then if you need to pause the video and go back and make sure this makes sense to you, you should probably do that. Okay, now d prime or d dx is going to be equal to this divided by 2d. So I just need to divide both sides by 2d now. So d prime or d dx, doesn't matter how you identify your derivative, is going to be, and then up here, I did some simplifying. Again, I encourage you to simplify that numerator on your own and then come back and see if you agree with my simplification. Okay, so this is my derivative. Yes. Okay, now I want to set it equal to 0 and solve. Now remember, I only need to have the numerator equal to 0. Let me make sure I got this simplifying right for 2d. I got to do one more step here. Sorry, this d I need to turn into an x. So remember, d is all of this. So this would actually be 2x minus 8x plus, oh, no, let's just write that as minus 3x. Sorry. Minus 3x plus 2x to the third over 2d. So I divided that 2 already. D is x squared plus 2 minus x squared squared. Okay, I know that part was a little weird. Pause the video and go back, make sure that makes sense to you. Basically, I put this square root in here for d, and then I also divided that 2 into my numerator, because this would be negative 6 and this would be 2. So I divided 2 into everything up there. Okay, now I want to set this equal to 0. If I want to find out where it's 0, I really need to only check the numerator. So I need to solve that equation right there. And I can factor out an x or a negative x, doesn't really matter. I'm going to factor out a negative x. So I get 3 minus 2x squared. So that's going to mean that x equals 0 or x equals plus or minus the square root of 3 over 2. So not the nicest number, but we can work with that. Again, we're going to ignore the negative. And then we also need to remember, if this is the function that we're taking the derivative of, these are critical points, but this denominator also can't equal 0. If you set this denominator equal to 0, you're going to find out that that never happens, basically because of these x squared. So I'm going to say d prime is never undefined. Okay, so these are my critical points that I need to check. So I don't want to do the second derivative this time. So I'm going to do first derivative test. So positive square root of 3 over 2. And if you do your sign chart, actually I do need to check the negative this time because it's a coordinate point. Okay, so I do need to check both because I forgot. We're not doing we're doing a coordinate point here, so I do have a negative. If you do your sign chart, and remember we're checking d prime here, we're going to get negative, positive, negative, positive. Double check, make sure that you could do that sign chart. So that means my original function is decreasing, increasing, 0, decreasing, increasing. So this is a min and this is a min. Remember, I'm looking for the minimum distance. So these are the dimensions that I want. So that means a min distance occurs at x equals plus or minus the square root of 3 over 2. And those coordinate points are negative square root of 3 over 2, comma 5 over 2. Again, you're going to plug this negative square root of 3 over 2 into your original function, and positive square root of 3 over 2, comma, positive 5 over 2. Okay, so that is example 2.